Now, one thing that we have to know for AP Physics C is the electric field energy density. And that is basically refers to the fact that in any electric field, energy is actually stored in the electric field. Now, you may say, oh, energy is stored in the capacitor, but even in an electric field without a capacitor, there is stored energy there. The electric field energy density is just the energy stored per cubic meter in the electric field itself. And let's see if we can derive that with our capacitor energy equation. So I'm just going to draw a capacitor right here. This has got area A on that plate, same as on this plate. And it's separated by a distance D right there. Plate separation, D as always. Well, how much energy is in there? Well, let's use our, say it's got charge Q on there. Just say this is the positive and this is the negative side. The field lines go right from here to here. And this has got a field E in there. And there's actually energy stored in that electric field per cubic meter of the field. Now the field fills this whole space between those two plates. So I want to get the energy density. That is simply the potential energy divided by the volume. Use V for volume. So that is simply this. The potential energy of our capacitor is 1/2 Q delta V. What's the volume of this space in between the capacitor plates? Hint, it's area A of this plate right there. That's area A. Distance D between them. The volume is just A times D. So now we may recognize a few things here. Notice that my potential energy per unit volume right here is 1/2 Q delta V over AD. But what is Q over A? Q over A is just sigma. This part right there, that's sigma. And what is delta V over D? Delta V over D, because delta V is negative ed, and we don't have to use negatives now because beautifully, capacitors, all you need is the magnitudes. This is just the electric field in there. So 1/2 sigma times E, the E field, and then I'm just going to use one more relationship here. The electric field in between these two is sigma over epsilon naught. So I can express this sigma as just epsilon naught times the E field. That's what that sigma is. Again times the E field. And this just is from the E field to sigma over epsilon naught. So what I get is the energy density. We use the little symbol U. It's can be difficult because it's a lowercase u. It's lowercase. And that is equal to the U sub E is the energy density of the electric field. It's a lowercase u, and that is equal to 1/2 epsilon naught times E squared, which is a very useful thing. Even if you don't have a capacitor, if you've got, this is the energy per cubic meter stored in any electric field. If you got an electric field, it takes energy to create that, and that is the energy density.